Good morning, ladies and gentlemen. Thank you for joining me here today. Uh, as Autumn said, my name is Basheer Azizi. I run OpSmart Global. Uh, that's that's part of what I do. I do many things. I'm also very involved in Washington County in developing the entrepreneurial ecosystem and encouraging new entrepreneurs to come into the tech sector. So as I was hearing the speaker today mentioning about supporting one another, it just occurred to me, a term came to my mind. I was like, brothers and sisters in tech, because that's how I felt, everybody being there. And so technology is, all I have been my whole life. When I was in ninth grade, I used to skip PE and instead sit in the computer science lab and write DOS commands to bypass the printer and print directly, bypass the administration and just print directly to the printer using LPR commands and not have to pay for them. But I also used to solve problems, and the computer science teacher used to like me a lot. But that was early on the motivation to get into technology, and that has been my whole life. Quickly, in terms of OpSmart, I worked for a company called Blackboard in mid-2000s, and we were committed to building the first learning management system, I want to say, in the country, and one of the largest. So if you haven't heard of Blackboard, Blackboard is like the Microsoft of the education industry. We dealt with over 2,000, at that time, 2,000 colleges and universities who used the platform. So imagine Zoom today. Blackboard is like that for the education industry. My job was in the back end, of course, running the data centers and helping with the hosting side of the business. Pretty much every college and university that wanted to leverage a learning management system, they were not as advanced in tech. So they could not build their colos and their servers and actually use the product. So what we had to do was build out colo space for them, build out the servers, and roll out their LMS so that they could actually use for their students. What that meant was a lot of servers. I was part of a team where we had to maintain 13 data centers across the world, over 10,000 virtual servers. That's a lot of IT assets to track, to manage, and make sure that they're always running, because online learning, as you imagine, has to be available 24/7. That's part of the online learning promise. So very quickly, we ran into a lot of issues that would come my way. Things like, how many virtual servers do we have out there? Who do these servers belong to? Why are we having outages? When we do have an outage, how do we quickly contact those universities or clients that are impacted and not everybody else? So all of these questions that came up, we needed to solve them. As technologists, we have to solve problems. One of the things I've learned in my career, you can't run away from tech problems. You have to solve them. You can't hide them. They come right back the next day, so you might as well just solve them. There was no off-the-shelf commercial product, and I guess surprisingly to say, even today, there is no holistic approach to this. The problem that I will highlight, the challenge is, as we moved from co-location to virtualization, hybrid, as well as all the way to AWS, entire public virtualization, the problem, it touches multiple disciplines within your IT operations, and that is what I will be highlighting. So I proposed a solution to Blackboard and asked for a dev team, and we started rolling up our sleeves and started coding. And we actually built a product to address a problem, a business problem for Blackboard. So we built the product, and at some point, I started to see that this problem is actually recurring within the industry, mostly for larger enterprises, but also mid-sizes as well. These problems start to kind of raise their ugly heads when you have over 100+ virtual servers. When you're less than that, below that, you could probably get away with managing within spreadsheets and kind of duct tape your way. But as soon as you scale to higher numbers of virtual servers, then you start to see these problems that come up. So I proposed to Blackboard an idea. I said, let's take this product to market and let's make money out of it. Blackboard It's a giant company. It was acquired for $1.2 billion. They were already making plenty of money. They said, we're in the education industry. We're going to stay where we are. We're not going to pivot to a new industry where we're selling software now. So I said, okay, well, let me buy it from you. Let me acquire the intellectual property. And they said, you know what, that's a great idea, because now we get to have a commercial vendor that supports this strategic product for us, because it was a critically strategic product for them, supporting their platform. That is how we were able to establish OpSmart Corp, and long and behold, Blackboard was client number one, and then some of the bigger entities, we had some networking and connections, power of networking. We were able to start to get other larger entities interested. So, Blackboard was one, then IBM came along through Blackboard, then VirtuStream through Dell. CTC is actually equivalent of, you could say, AWS in Tokyo, Japan. So I had to fly all the way over there, deploy the system for them, and train them in Tokyo on how to use it. And Vodafone is in Europe. They're also, you could say, Verizon in Europe, using the product, larger enterprises, and so forth. And that is how we grew. I grew up in Montgomery County and went to Seneca Valley High for one school year in Germantown. Went to Montgomery College, University of Maryland, did 2 masters there, masters in technology management, and then went back for an MBA to be able to run a startup. Did all that while growing the company. And this is today, this is where we are. Okay, so pivoting now towards the challenges, because that is what I'd like to highlight, the challenges when it comes to cloud management and how do you address them. Regardless of the industry you're in, when you're leveraging cloud services, cloud as in cloud virtualization, and you're getting an AWS server, Azure server, or any type of server, and you'd like to push some type of a service, even if it means subscribing to AWS, for example, you're providing some type of a service that is interfacing with a customer. There is the actual cloud management of knowing how many servers you have, what you're paying for, how you're leveraging those. Then there's the automation. Again, the concept of automation kicks in when you scale and grow. And so these are the 3 core disciplines within cloud management. And that, it kind of trickles down to asset visibility, knowing what you have, having control over what you have, and then being able to automate what you have. Automation is a key component of successful cloud management. Okay. When you do deploy a strategy like this, what are you trying to gain? You're trying to gain by reducing your cloud costs. I come across many clients who are getting a bill at the end of the month from AWS, and they get shocked because when they transitioned from Colo, their cost was $200,000 a month. Now they're getting a bill from AWS for $300,000 a month. They thought they were going to save money going into AWS, but they're not. And there are reasons for that. A lot of it is waste. A lot of it is mismanagement, misconfiguration. Then there's visibility and control of cloud assets. I come across customers who deployed virtual servers, snapshots, backups, and there's no holistic process to have some type of a control. For example, you have a DevOps engineer that is updating your finance DB1. He doesn't want to take the risk of directly updating it, so what does he do? Takes a snapshot, just flyby snapshot of that. It happens to be a 500 gig server. Now he literally just doubled the storage space to a terabyte. He takes a backup of it, he applies his upgrade, life goes on. 60 days later, you find out you're still being billed for that snapshot. So you're getting a bill for Finance DB1, but you're also getting a bill for the snapshot of the developer who did not go back and clean up. Now, if you have policies and you have control of the assets, he won't be able to do that. Or there would be reminders. Even if he's doing it, it's for 24 hours, for a week, but there's some way to go back and take care of that. Then there's APIs, automation, provisioning. To leverage the cloud and still maintain costs under control, you have to be able to apply automation. What does that mean? To be able to deploy virtualization, but in a in a restricted way so that you can't have an engineer go to your AWS account, Azure account, or Google Clouds and create anything he wants. In reality, he needs a VM with 12 CPUs and 64 gigs of RAM, but he goes there and selects 64 CPUs and 100 gigs of RAM. Or in container-based, it's the same concept. It's not going by a specific bill of material. You can apply those types of policies and rules using automation and provisioning, but then also being able to reclaim unused resources, to be able to track what you have out there, and then constantly going back and reclaiming that unused capacity. There's a compliance and policy enforcement, of course, that you can apply to your cloud management with this methodology. Then there's a services correlation to cloud assets. This is critical because if you have a certain class of services being provided to your customers, and then you have so many servers out there, you need to be able to correlate that, and a lot of times in real time. So if you've got, let's say, 3 categories of the product, bronze, gold, silver, and you have so many virtualizations, you have to be able to connect those. And how do you do that? Using configuration management, which is where I will be going to next. So whenever we try to do an assessment, this is translating all that technical jargon into real-life problems that we see. A lot of the folks I work with, C-level folks, CTOs, CIOs, this is reality, that kind of behind the curtain. So in the forefront, you see polished advertisement, this great company doing wonderful things. When you sit down with the CTO, he's pulling his hair and he's like, help me. This is what's really happening in a lot of, you'll be surprised, I won't name logos, but larger entities, where they don't know how many virtual servers they have out there. And the further it grows, the more it gets out of control. So you sit down, for example, this happened, as a case study. There was an SSL vulnerability that came out, and it was a 0-hour SSL vulnerability on Apache servers. We had a client, they had 6,000 plus VMs. They needed to know quickly on all their Linux hosts, Linux-based hosts, which Apache servers qualify for this. It took them a week to get a list together. And it was major risk, major risk. Those servers could have been exploited. And major logos. When you have an outage on these things, you're talking about $20,000, every 5 minutes. It's huge loss of revenue when you have outages like that. And so visibility, these are real life, and there's many more of these issues that we come across. So we sit down with CIOs, directors of technology, decision makers at a much higher level, and say, okay, what you need is something called a CMDB. Who's heard of a CMDB? Okay, Jonas, of course. So configuration management database. It's a very good term, but it also it brings back some very, very sad memories for some people because it's not easy to deploy. It's not easy to actually implement. It can eat up a lot of money and still not yield results. But if it's done correctly, and that's essentially our expertise, that's what I have done my entire career, you can achieve amazing results. So the methodology is your CMDB first. Configuration management database, to break that down into kind of regular terms. Configuration management database, all it means is a source of truth, a source of sanity, one place where you have reliable information. Because when you're managing an enterprise that has hundreds and hundreds of servers, very quickly you lose control of IP addresses, MAC addresses, location of it, the data centers, classification. My goodness. Remember the finance DB1 server I was talking about? Well, just imagine if that is classified as staging or it's classified as test and not production. When you have security alerts come out and you need to apply an upgrade to it, you need to quickly know where your finance DB1 is. And if it's misclassified, then you run into problems. So configuration management is having a central location. It can start with spreadsheets when you're small, but as you're scaling and growing, you have to quickly think about a long-term strategy, because that will be your answer to taking ownership of your data and the assets that you have out there deployed. Nowadays, of course, DevOps is, the great best thing ever happened. We used to implement features into software in production every 2 weeks using waterfall methodologies. Agile came in, so we got faster, but now DevOps is on the fly. It's like changing an engine on a plane while it's flying. That's how DevOps is working. But it's also introducing a lot of risk that needs to be mitigated. So nowadays you see the features and functionalities in software products that all of you use, whether you use WhatsApp, Facebook, any of these sets of softwares, you see new features pop up just like that. That is the power of DevOps. What we say is, hey, let's not be so narrow-minded with narrow focus on features and functionalities, but let's also use DevOps to strengthen the back-end management of your cloud. So DevOps, while they're building features and functionalities, they can relay information, certain aspects of information, to your management systems so that the management system is aware of those features and functionalities and can act upon them. Okay, I'll skip that one. All right. So this is a case study in the case of Blackboard where the challenges I was personally dealing with. We had over 2,000 universities using Blackboard, but we didn't really know all the universities. Who were our customers? There were customers that had tried the product, decided not to go with. They were on the client list. There were customers that used the product for 6 months and canceled. They were on the client list. There was a customer or customers that signed up, paid for it, but they were never checked as production, so they were still as a prospect. And they were not making to the list. And so think about that. If you don't have a proper list of your customers, how can you provide support for them, operations? Then those customers, they sign up for certain contracts, certain number of users, certain amount of capacity. How do you know which contracts are correlated to those customers? That's information normally that sits in your CRM system, Salesforce, PeopleSoft, whatever you use for your client relationship management. That information needs to come in centrally using APIs. Then virtualization, the actual virtual technical assets that you have. That's another discipline. So we're combining data from CRMs, from your cloud platforms, bringing them centrally. We had no idea. We had servers that were marked as staging and test that were production. We had servers marked as production that were actually no longer in service. All those attributes or tags associated to virtualization is critical. And many companies, unfortunately, they fall behind because it's information that changes every single day. And so if you don't stay on top of it, very quickly your production servers are no longer production because the client's canceled and nobody went and changed the flag on it. You have clients that went production, but they're still marked as staging. So virtualization data coming in, and then your support systems. So this is your ticketing help desk systems where a client calls, they have an outage, you create a change management ticket or an incident ticket, and you follow through that to address the outage. All that information needs to come in centrally into your CMDB. Then you have your notification systems. When you have an outage, you need to be able to quickly notify. A lot of contracts are SLA driven. That means you have to be up 99.999% of the time. When you have an outage, that normally means a deduction of the bill. You have to refund the customer. A lot of clients ask for that. And so being able to track notifications and notifying them of outages and tracking that data is critical. Being able to track your project tasks, change requests in client environments, and incident tickets. These amounts of information, they come from different sources, and being able to bring all that and correlate them to a specific client in a specific contract, that's cloud management. And a lot of companies, they grow so fast, they have a product, they want to take it to market quickly, so they just jump and run and get on AWS, and they have no plan for all this. And so all of a sudden you get 50 to 100 customers, money's coming in, everything is going great, and then you have an outage. Oops. And that's a loss of major credibility that can mean, some businesses run out, they basically crash because of that, because of lack of proper planning. That's what makes cloud management so critical. So taking a step back now, these are the different features and functionalities that you would want to focus when you're thinking cloud management. So this is kind of bird's eye view, looking up and then coming down in different disciplines. There is the cost management, which is you want to control the cost of your cloud. As you're transitioning, if you're in whether you're local, as in using virtualization in your colo, or you have virtualization and hybrid. Some companies are still in transition. Some companies have entirely transitioned over to AWS. Some are shifting. They don't want to have all eggs in one basket. So they shift over to Azure, and they shift over to Zen and other technologies, Google Cloud, Oracle. And so the more you diversify, which mitigates the risk of being dependent on one vendor, now you've created a layer of complexity. And so you want to be able to have proper billing management, cost to asset correlation. That is key. When you have a number of virtual servers out there, you want to be able to map those virtual servers to clients and how much those clients are paying. So you have, sometimes we have come across customers, they pay $10,000 a month, but their cloud cost is $22,000 a month. When you have proper correlation visibility, you can see that. And so then you can sort by that and apply an algorithm that tells you, hey, 5 customers that should be canceled yesterday. You don't need them. Or address the problem to find out what it is. I'll go back to Finance DB1. Remember the DevOps engineer that doubled the storage to 1 terabyte? That doubled the cost of that customer, so there's no margin left now. Well, we don't have to cancel that customer because the DevOps engineer forgot to do something. We just delete that snapshot, and now we regain our margin. So billing management, all about billing and visibility and control on that and reducing cost. Then we have our Light CMDB. The best thing it gives us is visibility, cloud map, service correlation, event management, knowing what we have out there and what the state of our environment is. So we have 1,000 virtual servers out there. What's on, what's off, what's running, what's not running, what's production, what's staging. All that visibility is critical in a lot of cases for our help desk. The help desk engineers need to be able to see what is functional and what's not. And then the control of your cloud to be able to provision VMs, be able to tag attributes, virtual, and then being able to have VM to service links. Again, going back to the control and being able to do these things using automation. Applying policies so that virtual assets are not being deployed at will, but rather based on certain guidelines and bill of materials. So that when you are deploying a small-sized customer, and this is generic, it could be any type of product. When you're deploying a small-sized customer, an engineer should not be able to just randomly select 64 gigs of RAM because that's a small customer. There's a predefined set of guidelines for capacity. They should have 8 gigs of RAM, so you're not wasting resources. And then there's the correlation, being able to correlate all that data and make decisions. This methodology is utilized in many large enterprises to be able to make smart decisions about managing their cloud, about investing their money, about transitioning from platform to platform, about downgrading or upscaling the capacity of their cloud. All right, so zeroing in a little bit on OpSmart and how we solve this problem in the market. Our product, out of the box, when you deploy it, it has a discovery module. What it does is it asks for your user account into the different platforms using APIs. It makes calls and it brings in all the data that you have in AWS, Azure, OpenStack, VMware, many other platforms. So now you're not having to go to AWS and Azure, different portals, different tabs, and to see what you have and to do basic things like deleting a VM or creating a new VM or associating a VM, adding tags. All of that can be done from one portal. So that's the first problem we solve. We allow you to mitigate risk by not relying on one vendor, but at the same time, centralize all that information. So we give you a cloud map. We give you an activity dashboard on what is happening across your different clouds. We have infographics reports, of course, about what is going on. Virtual VM operations is being able to do the basic features and functionalities that you have for each one of those dashboards for each one of the providers. You can do all of that from within OpSmart. And then we have, of course, the billing, the volume, scale, capacity management, snapshot management, analytics, and much more. All of that from one platform. And this is to centralize your operations within one platform. But the cherry on the cake is that we also solve the CMDB problem. Because as we bring all that information into a central system, what we're doing is allowing you to correlate that data. We also have, besides our portal, in the back end, we have what we call OpsPacks for DevOps. So DevOps, again, this is it being the new way of how we roll out features and functionalities. What we allow for is back-end connectivity to additional systems, like your switches, routers, load balancers, backup systems, authentication systems, to bring additional data. So you could give me one IP address from your AWS. Based on that IP and MAC, we then go into all of these other tertiary systems, bring all that data in, and correlate it. So if you have a security system, all the security system will say is, hey, this IP address has 43 vulnerabilities. That's all it will tell you. It will not, any security system out there. That's where they stop. And as I said earlier, this is the challenge within the industry. Every vendor does what it relates to them. So the security scanning software will do an amazing job of scanning all the vulnerabilities and give you all this amazing data, but it stops at the IP address. Now it's your job to go find out who is that IP address. It might be, somebody's testing desktop under their desk, or it could be your finance DB1. You don't know that. But what we do is we take it from there. So we have the IP address, we have correlated data from your CRM systems, from your customer information, correlate that and say, oh, that's finance DB1 for Microsoft. You better jump, because that's an important system. And if it's got 43 vulnerabilities, everybody stop working. Focus on that. So APIs are critical for your cloud management. And what we do is we have OpsPacks for each one of them that you can enable or disable from within the system. And when you enable them, for example, for your backup system, you provide a username and password as a service account. We connect to that system, gulp all that data, make the correlation, and tell you, hey, Finance DB1 hasn't had a backup for 6 months. Or the last backup for Finance DB1 successfully ran at 4 a.m. That's good data to be able to make a decision. And then we apply automation to that so that you don't have to go and check on Finance DB1. When you have 1,000 or 2,000 VMs, you can't go check on each one. So now we add automation and say, hey, for all production servers that are of classification of database that belong to finance department, if there is a backup failure in the last 72 hours, make a list and send it to me. Or make a list and create an automatic ticket. So that is what I mean by automation. One of the, a unique case study or scenarios we dealt with was disk space. Disk space, running out of disk space is a very common problem, right? You have many outages because you ran out of disk space. It's just that simple. A log starts growing out of control, or you get, somebody hacks in and they start downloading a bunch of things, or the software just goes haywire and starts writing outputs that it shouldn't. But either way, or you actually have regular growth. The software is just growing, it's having real data, you ran out of disk space, and now you got an outage on your hand. So once you have this type of control, you can introduce, and we have done this, so we call this our absolute automation, where you have integration into the monitoring system that is monitoring your server. It sends an alert that says, hey, this disk is at 98%, and it's your Finance DB1, 2 o'clock in the morning. As soon as that alert comes in, the system automatically, OpSmart will take that alert and create an incident for it. Once it creates an incident and adds all that information, then it will make a contact to the storage system and say, hey, can you validate that this mount point, as in this disk space, is actually at 98%? And the storage system confirms it. Yes, it is. Then it applies another layer of automation. Can you give it 5% more disk space? And then the storage system says, yes, I'll do that. As the system is having this interaction, it's taking all the output and adding it as a log to the incident. And once it's done, OpSmart then checks with the server, says, are you okay now? Are you below 98%? It says, yep, I'm at 92%. Everything is green again. The ticket is resolved, and an email is sent out saying, hey, by the way, human, I found a problem, but don't worry, I fixed it myself. This is computers working, sensing their own problems and solving them. And that's where you slowly get into AI, where the computer itself knows what's wrong, validates that this is what's wrong, and fixes itself. You don't have to wake up 2 o'clock in the morning, be on call, and get woken up to solve a problem. And I have been through those on-calls for many years, getting a call 2 o'clock in the morning, Finance DB1 just crashed. So that is what the power of integration provides for us within cloud management. Okay, typically, because one of the questions I get is, how long does it take to make this happen? So it's 30, 60, 90 days approach. The first step is to deploy the product, deploy the system itself, do some basic data validation, and bring in a lot of data. Just gulp data into the system using service accounts. The second step is to actually start making the correlations. And a lot of times it's just a one-time setting the mappings of assets to clients to products correlation. Once we have all of that in place, then we move towards introducing automation. So automation plays a key role. If there's one thing that I'd like to have you go with today is automation in IT. If you're not automating and not constantly automating, you're falling behind. Because work, the way it was done in the past, manually having an engineer go and actually do something, that's changing. Now you have to be able to constantly evolve. And so you have to introduce automation. You can't achieve automation unless you know what you have out there, unless you have proper management and control of what your environment looks like. So once you've achieved the prerequisites, then automation, there's immense potential to it. There's a lot you can do to be able to achieve automation, whether it's reclaiming your resources, reclaiming your snapshots, virtual servers that have been sitting there and they're not doing anything. They're just running at 10% of their capacity. And we see this a lot in AWS, Azure. People deploy, over-deploy, and oversubscribe. And in reality, they're only using 10%, 20% of the capacity. So they could be saving a lot of money by having the visibility and introducing automation to reduce sizes when you're not using it. And then as soon as you see utilization going up, then you crank it up. And that is something you can do with automation and APIs into the systems. All right, questions?